In this video, we're going to take a look at exam revision for arithmetic sequences. So if you haven't watched the previous video on an introduction and finding the nth term of an arithmetic sequence, do check out that video. It will help massively before watching this video. However, if you do feel confident enough, let's get started with the very first question here. What we've been given here is the first 5 terms of an arithmetic sequence. We've got 8, 13, 18, 23 and 28. So we're asked to write down the next 2 terms and work out the nth term for the series. So instead of series, I just change that to sequence. The sequence here. Okay. So for the next 2 terms, what we need to understand here is what's the rule. So what are we adding or subtracting here to get to the next term? If we start off with 8, what do I add to 8 to get to 13? I'd simply add 5. Now to go from 13 to 18, what do I add? Well, that would be add 5. So clearly what I can see here is the rule is we add 5 to get to the next term. If we've got 28 here, and I want the next term, I'd do 28 plus 5, which would give me 33. And again, do the same here from 33, add 5 to that, and I get 38. Okay, so next 2 terms, write these down here. The next 2 terms, they are 33 and 38. That's the first part done there, so that's the next 2 terms. We now need to work out the nth term for the sequence. Let's just write this down here. So for the nth term, just remember that the nth term is of the form an plus b. So in this case then, if this is the formula for the nth term, what I need to find now is the an part, and the way we do that is to find the difference, which we've already done. We just add 5 to get to the next term. So my formula here for the nth term, write this down. This will begin with 5n to begin with. And now we need this plus b here. And the way we find that is to go backwards from the very first term. We just go backwards 1 time here. Well, if we're going backwards, we need to subtract 5 now. We just do the opposite of what we've done here. So 8 minus 5, that would give me positive 3 there. Okay, so my nth term here is 5n plus 3. Okay, and there we have it. So that's the next 2 terms are 33 and 38. And that's the formula for the nth term, and that gives us the solution to question 1. Moving on to question 2, now we've got an arithmetic sequence which has nth term of 3n minus 7. And we're asked to find the 20th term in the sequence. So if we already know the nth term here, the nth term here is 3n minus 7. And I can use this formula here for the nth term to find any term in this arithmetic sequence. Okay, so for example, if we wanted the first term here, if we wanted the first term, that would be when n equals 1. All I'd simply do here is substitute n equals 1 into my formula for the nth term. So that would be 3 times 1 minus 7. I'd get 3 minus 7, giving me minus 4 there. Okay, so the first term in this arithmetic sequence is minus 4. So what about then if we want the 20th term? So for the 20th term here, again, using the same idea that we've done here for the first term, this would be when n equals 20. That's when n equals 20. So again, I just use my formula here for the nth term. So it's going to be 3 times 20. I just put equals here just to show my working. 3 times 20 minus the 7. What I get then is 60 minus 7. And that gives us 53 there. Okay. And there we have it, so that's our solution to question 2. Moving on to question 3, now we've got the first 4 terms of an arithmetic sequence, so they're given as minus 1, 6, 13 and 20. So for part A, we're asked to find the nth term for this arithmetic sequence. So for the nth term here, just recall that we can express this here as an plus b. Okay, so that's the formula that we're going to use here for the nth term. So for the first part here, the an, that's given by the difference between each term. So what do I add to each term to get to the next one? So we start with the minus 1 here. What do we add to minus 1 to get to 6? Well, that would be 7. What do we add to 6 to get to 13? Again, that would be 7. And then finally, what do we add to 13 to get to 20? And we get 7 again. Okay. So the first part of my nth term here, write this down one more time. That will be 7m. because that's the difference here between each term. It's 7n. And then for the plus b here, we just go back one time. So if we go back from -1 here, what would come before it? Well, if we're going back a term here, we just do the opposite. So if we added 7 to get to the next term, go back one term, we just subtract 7. Okay? So -1 minus 7, and that gives us -8 there. Okay? We get -8 there. So that's part A done. That's the formula for the nth term. Now for part B, it says Bob says 40 is in the sequence, so show using the nth term why 40 is not part of the sequence. So remember, if we want to show that a number is or isn't in the sequence, what we need to do is use the nth term here. So what I do, I take my formula for the nth term and I set it equal to that number, and we're going to check whether it's in the sequence. Okay, I've got 7n minus 8 is equal to 40. What we do now is we solve for n. Remember, we get one of two outcomes. Either n is a whole number, an integer, and if it is an integer, that means that that number is in the sequence. And if we get a decimal, so it's not an integer, then that means that number is not in the sequence. Okay? So if we're going to show that 40 is not part of the sequence, what we'd expect here is that n is a decimal number. Okay? So we just need to solve for n here, so add 8 to both sides. We get that 7n is equal to 48. And straight away I can see here that we're not going to get a whole number, we're not going to get an integer for n. And the reason for that is because 7 squared, 7 times 7 is 49. So obviously if I divide 48 by 7 here, this will be a decimal. Okay, so n is equal to 48 divided by 7. And like we said here, if I just quickly put it into my calculator just so we can see what the decimal is. So 48 divided by 7, we get 6.85, 6.8571, and so on. Okay, so in that case then, because n is not an integer, it's not a whole number, so n is not an integer, this means that basically 40 is not part of the sequence, so therefore 40 is not part of the sequence. Okay, that's all we have to do there. So 40 is not part of the sequence. That's our solution. So that gives us the solution there to question 3. Moving on to question 4 now, we've got an arithmetic sequence which has nth term of 3n minus 5. We're asked to evaluate which term of the arithmetic sequence is equal to 97. So again, we've got the nth term here. The nth term is given already. That's 3n minus 5. 3n minus 5. And we're asked to evaluate which term of the arithmetic sequence is equal to 97. What I do here is I take my nth term, 3n minus 5, and I set it equal to this number here. We've got 3n minus 5 is equal to 97. Okay? Remember, what I'm doing here now is I'm going to solve for n. Okay? Now, if we know that 97 is part of this sequence, what we'd expect here is a whole number for n. Okay? And that whole number will tell us which term of the sequence 97 is. Okay? So solving for n here, I'm going to add 5 to both sides. So we get 3n is equal to 102. And now what I'm going to do is divide both sides by 3. So n is equal to 102 divided by 3. Okay? So 102 divided by 3. So in that case, then what I'm going to get here is 34. I get 34 there. So because we got a whole number, that means 97 is in the sequence, but we'd already expect that because we're told to evaluate which term of the sequence is equal to 97. But what this number, like I said, tells us is which term that is. So 97 is the 34th term in the sequence. Okay, that's what we're looking for here. So 97 is the 34th term in the sequence. And there we have it. So that's our solution to question 4. Moving on to question 5 now, we've got an arithmetic sequence which has nth term of 4n minus 1. we're asked to calculate the difference between the third term and the seventh term in the same sequence. So the nth term here is already given. So the nth term here is 4n minus 1. So if we want the difference between the third term and the seventh term here, what I need to do is just find the third term and the seventh term using the formula for the nth term here. So for the third term, this is given when n equals 3. When n equals 3 here, so just using our formula for the nth term then, it's going to be 4 times 3 minus 1. That's going to be 12 minus 1. And that will give us 11 there. Okay. Now for the seventh term, we just repeat this here. This time n will be equal to 7. This is going to be equal to 7. Oh, sorry, I should say 4 times 7. Do it in that order. Doesn't really matter, but just keep it consistent. So 4 times 7 minus 1. So 4 times 7 is 28. Minus 1. And we get 27 there. Okay. So now if we want the difference between the third term and the seventh term, the difference here, that's going to be the seventh term minus the third term. Okay. So in that case then, we're going to get 27 minus 11. And 27 minus 11, that would give us 16 here. And there we have it. So that's our solution to question 5. So if we take a look at the very last question here, then we've got the first 4 terms of an arithmetic sequence, and they're 4, 11, 18, and 25. So for the first part here, part A, we're asked to calculate the nth term of the arithmetic sequence. So for part A then, let's just recall that the nth term here is given as an plus b. Okay, so we need the an to begin with here, and the an part here comes from just checking how much we add or subtract to get to the next term. If we start with the first term here, 4, what do I add to 4 to get to 11? Obviously it's an increase in arithmetic sequence, so I must add 7 here. What do I add to 11 to get to 18? Again, that will be plus 7. And what do I add to 18 to get to 25? Again, that will be plus 7. Okay, so my nth term here, again, if I just write this down, nth term, because we're adding 7 here, this will begin as 7m. And what I need to check now, what would come here before the 4. So what number would be here? So we're going backwards now. So to go forwards, we add 7. To go backwards 1 term, that means we do the opposite. So we're going to subtract 7. Okay. So 4 minus 7, that gives me minus 3 here. Okay. So my nth term here is going to be 7n minus 3. Okay. That's the nth term there of the arithmetic sequence, giving us our solution to part A. Now for part B, we've got the nth term of another arithmetic sequence, and that's 2n plus 7. Let's just note this nth term here. Like we said, that's 2n plus 7. Now we're asked to determine whether 45 belongs to the sequence. Okay. If we want to check here whether this number belongs to this sequence, and we've got the nth term here, all I do is I take my nth term here, so 2n plus 7, and I set it equal to this number. Okay. And what we're going to do here now is just solve for n. So subtract 7 off both sides. So I'm going to get 2m is equal to 38. So 2n is equal to 38. So therefore, if we divide n now by, if I divide both sides here by 2, that's going to give me n on the left-hand side. And 38 divided by 2 here, that would give us 19. Okay. So what does this show us here? Well, because we've got a whole number, an integer for n, what this shows us here is that 45 does belong to the sequence. So therefore, 45 does belong to the sequence. So 45 does belong to the sequence. And in case you're wondering here then, what does this 19 actually represent? That tells us then the 19th term in the sequence is 45. Okay, so 19th term, the 19th term here is equal to 45. Okay, and there we have it. So that's our solution to the very last question. That brings the end of this video on exam revision for arithmetic sequences. So in the next video, what we're going to do, we're going to take a look at expanding brackets.